Audio recording for this meeting has begun.
Welcome to the third webinar in the context of the European Master in Official Statistics. My name is Heli Lehtimäki and I am hosting this session in Eurostat. Today's webinar is about innovation in official statistics and multi-source statistical production. It will be delivered by three speakers from Eurostat, Emanuele Baldacci, Dario Buono, and Niki Stylianidou. Emanuele is currently Director of Methodology, IT, and Corporate Statistical Services at Eurostat. He arrived here with us 2 years ago from the Italian Statistical Office, ISTAT, where he was the head of the Integration, Quality, and Research Department. Before that, he had worked for the International Monetary Fund, World Bank, and also served as a chief economist at the largest Italian trade financial group. Emanuele holds PhD in demography and has written several scientific publications. These days, Emanuele is much into innovation and how to prepare our statistical production systems to meet the future challenges. Emanuele will introduce his colleagues later on, but for the benefit of those who might join us for the first time, let me just quickly recap in few words how this webinar works. As a participant, you can watch and listen to the session. Do not switch your webcam on. For interaction, you can share your views and the question in the chat room and use signs on the top of your screen. At the end of the session, you can download the presentations and I will send you the link to the recording later. And now, without further delay, let us move to today's fascinating topic. Emanuele, floor is yours.
Thank you, Heli, and welcome to all the participants who are following us from all around Europe. I can see your names and in the chat area. This is also the area that will be used to exchange, ask questions and exchange comments between participants and between participants. I'm here with two colleagues which you don't see so far on screen because they're sitting on my side. Dario Buono on my right, Niki Stylianidou on the left side. They are working in Eurostat on methodological issues and innovation projects. They will tell you in later during the
Emanuele, may I stop you a little bit? If you would stay stable by the phone for the audio, because you move sometimes to the chair and the voice comes and goes. So to get it.
Okay, I'll try to speak closer to the phone, so probably the quality of the audio is a bit better. I was about to say that they will introduce themselves and what they're doing in particular in Eurostat when it comes to their turn for their presentation. In fact, what we did for today, we prepared as a trio, 3 blocks of the presentation, hoping that this is more lively and triggering more questions and interest from your side. So my job will be to introduce the topic of innovation in statistics and what is the data revolution ecosystem in which statistical offices will have to operate in the near future, what this implies for the way we are working in official statistics. Then I will give the floor to Niki, who will be talking about the innovation portfolio for the European Statistical System. What are the activities that are currently ongoing with a view to modernizing a statistical office and statistical production in Europe? And then we'll move into more specific methodological issues, including what are the key areas of innovation in official statistics, how to harness the big data revolution, and what are the challenges and the research areas. I hope that you will be helping us along the way with questions, comments, any views that you may want to express during the conversation, and we also have allocated some time to Q&A, but please feel free to send your comments while we speak using the chat so that we can use it as an input for having a more interactive presentation. I put on screen, and I hope you can all see the presentation, the 3 blocks that I was just going to cover. For my part, which is about the digital statistical landscape, I want to briefly cover three things: the technology trends that we see having an impact on statistics, what are the consequences for what I call digital era statistical production, and then the concept of smart statistics that we will be hearing increasingly more in the European Statistical System more generally. So, but let me introduce quickly a couple of more general points, because some of you are not coming from a statistical office and may not be fully aware of how official statistics is organized. In this slide are the blue fish, and the blue fish is supposed to represent high quality statistics for Europe, as the slide says, in an ocean of information. And the ocean of information is becoming increasingly populated by several different fishes of different quality, size, colors, if you want, which represent different data sources that are increasingly used to communicate about phenomena that could be relevant for decisions to be made at political level, individual level, at any level. We are living in a world, as you are all aware of, that is increasingly based on empirical evidence. Facts are used in several cases and occasions to bring an argument. At the same time, facts sometimes are also misused, or let's say fake facts are provided to support positions. So there is really a need from the user's perspective to have sound, certified, quality information, and official statistics provides an infrastructure and a product that delivers this in an increasingly differentiated and complex information environment. For those of you who are not familiar, just let me quickly remind you of how the statistical system is organized in Europe. We are a partnership. It's the partnerships and the flags that you see in the slides. A partnership of Eurostat, which is the organization for which we work, the European Commission Statistical Office, and the Statistical Office and other national authorities that are involved in statistical production in all the countries of the Union and also the EEA and EFTA countries. So it's a big partnership with many producers of statistics. And it is important to keep in mind that our partnership is based on a division of labor. And you see in a highly stylized way what the different components of the systems are responsible for. So if you start from the top, the ESS, which is the system, the partnership, defines the definition, the methodologies, the concepts that underline the statistical dimensions that need to be measured. At national level, the statistical offices are responsible for collection of data, but also for processing of the data, application of methodologies, and production of statistics at national level. And then at Eurostat level, we consolidate all this data and we produce European aggregates, which are also relevant for European policy. So it's really an integrated production chain where different actors are put together and co-responsible in the end for the product that we are delivering, which is statistical information of high quality for Europe. Now the data revolution comes, and this changes the picture dramatically, and I will try in the next 10 minutes to convince you that this disruptive change is for the best, and that we should be reaping the opportunities that are coming from this change. The typical traditional way in which official statistics operate is to collect data through surveys or administrative data, process this data, and deliver statistical products. But the world is changing rapidly, and we have several technology trends that will change the landscape in which we are already living and in which we will be living in the near future. Here in this slide, I just wanted to highlight three areas where this change could be dramatically having an impact on the way we work. First thing is that the availability of new data sources, it's growing dramatically. These data are used to produce services in different industries. If you think, for example, of apps that are putting in contact different users of services. Here in the picture you will see, for example, a very well-known platform that provides these peer-to-peer services for mobility in urban centers, Uber. And well, this is an example of how the digitalization and the data can lead to services which did not exist before and where the data can be leveraged to provide something that didn't exist and can serve a user need in an area that is not statistics, but it's a good example of where the world is going, so to say. Second thing is an innovation that we are now increasingly learning to use. It's robots and information remastering. Increasingly, machines will do work of that was in the past a responsibility of humans. Just today, for example, I learned the news that in the Italian Parliament, a member of Parliament was introducing his speech in front of the other members of Parliament through a robot that was doing the introduction, running the introduction of his speech. And we are aware of robots or algorithms taking already decisions and sitting virtually in the boards of financial institutions and making decisions on financial operations. So machines taking important responsibilities in terms of making decisions which are based on evidence and automated processes. And then the third big development is what Tim Berners-Lee had, the inventor of the web, had forecasted, the emergence of a semantic web, a system of interlinked data and metadata, we would say as statisticians, so information about the data, that can provide a cloud of interlinked information that could be used for different purposes. This is not a reality for tomorrow, it's really what is happening right now. And with this, you have a lot of consequences for many different information market sectors. First one is affecting all of us, and is the question who is owning the data in this world. If we are talking about data that we are providing to platforms that are giving us back services, these data are stored in these platforms, so they are not ours anymore. Typically, we are agreeing to a certain use and reuse of the data. So the issue of the legal ownership of the data is becoming increasingly important. In the past, if you think about the traditional way in which statisticians would operate, we would have a legal framework in which we would be allowed to request information from users, typically through a questionnaire. In the past, this questionnaire was a paper questionnaire. And then on the basis of this legal framework, we would access under very tight limitations to protect data confidentiality, the data to produce statistical services. Now this has been much more blurred, particularly in the world of new platforms and big data, as personal data can be stored in platforms that can reuse this information to provide services to others. And for example, a critical example of what I'm saying is the use of this information by social media platforms that are probably knowing us better than we do, as some journalists put it, by putting together different information that we are leaving just by using our telephones or tweeting on social platforms or providing other types of comments. And this has implications also for the information market products and services. What we are observing is that the value is for companies is increasingly focused on the use of the data to produce services that that customers will consume, rather than in the data themselves. So if you were to use an economic terminology, you would say that data are becoming a commodity, something that is very cheap to produce, that you have abundance of, but that is not of extreme value in itself. It becomes valuable, it creates value added, again, to stay with the economic terminology, to the extent that you add on top of the data other services. Services could be visualization services that would help explain what is behind the data. Could be storytelling mechanisms that are putting together different points of information. It could be models that allow you to predict the present or even the future, so to say something about what is happening in real time. So the big consequence of the digitalization and the abundance of data is that the data themselves are more abundant, cheaper to produce, in themselves not really valuable unless you do something with them that is of use of the consumer. And this is true for social platforms, it's true for utility providers, telecom companies, and it's true also for statisticians. And let me just go to this point, which is the most important one to open our conversation on the future, on what the statisticians should do in this innovative environment. What is the impact of all this set of developments on our work? Let me start by saying that we are facing challenges. This revolution, the data revolution, is not happening in a vacuum or in an equilibrium. We are facing challenges that we would need to solve with or without the data revolution. And this is that people are increasingly tired of answering questionnaires. So the non-response rate in statistical surveys is going up. You have fewer and fewer respondents that are willing to provide information. There is a general concern of the economic cost of collecting information from individuals, from companies, in some cases from institutions, and this is the so-called response burden. For some countries, this has been even translated into a cost, and the share of this cost in terms of GDP is quite significant according to many estimates. So the cost of responding to statistical offices is considered part of the red tape or the cost of bureaucracy. Obviously, statistical offices don't do this just for pleasure, but they also give back to society important information products. But this cost and benefit analysis is very important and is becoming increasingly binding, particularly because governments are much more stingy with the way they're allocating their resources. So what are the areas in which the innovation in the technology environment and the abundance of data, the new data ecosystem, what are these areas that are of relevance for statistical production? In a nutshell, this slide says that everything we do will be affected and is going to be affected by the data revolution. And in particular, if you think about our job as transforming raw materials through processes into products and services that are offered to society. So we are like a factory, in fact. We are using these raw materials. In our cases, these are the statistical data sources. We are transforming them through methods into statistics and statistical indicators. And then we are designing statistical products and statistical services. This is what we offer. This is our output that we offer to society. It could be an indicator. It could be a dashboard. It could be a forecast of something, population forecast, for example. And it could be analysis on the basis of the data which tell society at large what are the conditions of the economy, social dimensions, and environment, for example. So let's go one by one in these four areas, the data sources, how you combine the sources to create something that is called the statistics, the factory, so the engine that will need to be used to do that, and the products and services that we produce. And I will do this having in mind that the transformations that I was mentioning are going to be continuing as a trend, as a technology trend over the next few years, as all the experts tell us will do. So how will this affect our work? First, let's take the sources. If you speak to a statistician today in an NSI, what are the statistical sources that are used for production of statistics? They will tell you it's a combination of data collected through surveys and data that are coming from administrative registers that we are trying to combine subject to quality requirements, to standard methods, and we produce statistical analysis on population, for example. Well, in the future, this will be a much more complex environment because we will have the beauty and bounty of several different additional sources that could be used by statisticians to produce more information services, more statistics. And in this slide, you will just find some of these so-called big data sources or new data sources, which are not traditional sources used by official statisticians so far. Take, for example, under the column of sensors, further down, the last block is satellite imageries. And satellite images are typically not used in statistics, but there are examples where you could show that they could be used with sophisticated algorithms to have an estimate of land use or crop and agricultural production. Or take communication systems data in the first column from the left, and here you have data from mobile operators, which could be either network data or mobile phone data. How many telephone calls an individual is making and what is the length in which area the telephone call is made. These data have been tried and piloted in some experiments that will be discussed later in this conversation. And we show that there are positive results in terms of their possible use for estimating population stocks, so to say, so the population in a certain period of time, the mobility of the population, so how many people move in and out cities, for example, and even tourism statistics, so how many people are moving into a certain country or a certain place for touristic reasons. Other data can be also used from sources which are not traditional. For example, the web. You can grab information which is already available on the web and try to make sense of it and help you understand statistical dimensions of interest. For example, you can try to get information from web portals on job portals, and you can have information on whether there are skills that are demanded or whether the number of job vacancies in a country is high or low. Then what you need to do is to combine this data together, and this is with a technical terminology called data mashups. This is the future of statistics, if you want, and why? Because we are used to a one source, one statistical product relationship, while in the future, given the complexity and variety of data and sources, we will have to link and match these different data to produce statistics. Obviously, this is complex because in a survey environment or in an administrative data environment, we have unique identifiers that allow us to link individual records in one archive or in one data set to another. In this case, the variety and structure of the data is so complex and different from one source to another that we would need to use more sophisticated methods and algorithms that allow us to combine information that is not been structured by design to be used by statisticians. This is what many of our colleagues are working now on, and we had a recent hackathon in Brussels involving more than 60 people from 22 different teams coming from national statistical offices in Europe, where our experts have been working on doing exactly this on a sample of data related to labor market skills. And then we'll need a new factory that is based on the concept that the data will have to be integrated and will have different sources. If you talk to a statistician today and you try to explain how, or you try to ask him or her, how are your data stored in a statistical organization, they would make a reference to a data warehouse, which is a very orderly approach to storing the data and querying the data, so navigating the data to extract the type of information you need. If you ask someone who is working in Google today how their data are organized, he would mention concepts like data lakes or data pool. What are these things? These are data sets, complex data sets that go beyond the data warehouse, because the data that are pooled in this pond are not structured. They are not integrated ex ante by design. So what you would need to have is expert systems, intelligent and smart systems that allow you to combine this data from different sources. And this is again an area that needs to be, where investment needs to be made for statistical organization to be able to reap the benefit of this data revolution and look a little bit like the factory that we have shown here on these slides, where the big data are a sort of mine or oil reserve. They are extracted and then they get into this machinery where they are enriched, cleaned, integrated, and then used for statistical production. While this is very highly stylized, it tells us, for example, that it doesn't make sense to have silos in our organization. So dedicated production lines to, let's say, specific statistical domains. Census data separated from economic data, separated from social data. And then finally, on the end part of the production, we need to also look into what are the benefits that this larger variety of statistical sources and the ability that we can have to combine them will give us in terms of new statistical products and services. And here, let me use just for simplicity one single metaphor, if you want. We are still living in a world where, although we are using digital technology, in fact, we are offering to our clients the equivalent of a paper statistical yearbook of the past. Tables which have been designed by the producers, by us, that tries to interpret as much as possible the needs of the users, but these tables are not interactive. They are fixed, and you can scroll the pages, go from one table to another, but there's a limited flexibility in the way you are going to be able to use the data and consume the data. Now, the world of the future, and you as a natural consumer of information in different forms, not only statistical information, but for example, just the way you access the media, you are an example already of the type of engagement that you have with the information providers. You don't want to be prompted fixed information. You want to navigate the information. You want to have the information tailored to your needs so that you can answer the question that you have. In principle, the statistical office webpage would need to be evolving towards the Google webpage, the Google search webpage, where a user interested in something would write a natural language query, like what is the condition of my country, and be given back information that is tailored to the specific demand by a system of data and data processing tools, and this is the statistical office of the future. This is what the statistical office of the future will need to do. At the same time, the statistical office will need to speak a language that the user or the consumer, if you want, understands. So a simple language and simple services that are based on the data, that explain the data, and that can give answers rather than just purely statistical products. People are not so interested in having an inequality index per se. They are interested about the level of social cohesion of a country, the level of income disparities in a country, and they are interested in a story, in an answer that provides the different angles. This is where we will be evolving in the next years in tailoring the information towards our users in a way that they are feeling that they are in the driver's seat when they are consulting our web pages or our apps or our videos or other channels for communication. Let me stop here for a second and take a couple of questions. I see that there is already one volunteer that commented from Switzerland. I think you all see the comment in the chat. I'm reading it loud now. Thinking about data mashups with the traditional features of data quality like reliability, usability, relevance, apply to data produced by data mashups. So questions, I guess, is how can we ensure that the quality of this combination of data from new sources will be equivalent to the level of quality that we have today? And this is a very good question. I think that the answer is not a simple yes or no, obviously. But let me make two comments on this. First, this is an issue that sometimes people associate with the 4V of big data. And one of the 4 V's of big data is veracity. So is the source of the data reliable? And this is a very relevant problem, because if we use, for example, Google search results to produce indicators that are leading indicators of economic phenomena. So, for example, by just searching the frequency of the word recession in Google, you can plot it against the GDP and discover that this indicator is very much correlated, in fact is leading in some cases macroeconomic indicators. Then the obvious next step would be, well, why can't we use this indicator to produce more timely GDP figures? Perhaps instead of waiting for 30 days to produce GDP after the end of the quarter, we could cut this down to a couple of weeks, even if the quality or let's say the size of the revision to the indicators will be larger than the current indicator, we may still have some good signal. Well, but think for a minute what happens if Google changes the algorithm that is behind the Google search, without obviously asking the statisticians or even telling the statisticians what has happened. Well, you will have an impact on the quality of your data that you are using in the process of estimation. So the question, and this is just a possible example, is how are you going to deal with it? Another example is, again, making specific examples of cases that have been already piloted in the statistical community in Europe. We could use Facebook comments and Twitter comments to produce a sentiment index, an index that would tell you whether the population in a certain country is, on average, optimistic or pessimistic in general, or about a specific point, a specific topic. We can do that by just analyzing the text through text mining tools and trying to derive a quantitative indicator that is very similar to what some statistical offices measure by business confidence and citizens and consumer confidence indicators. In fact, in some countries like the Netherlands, they have done this and they have found that the indicator is quite good in predicting the level of the consumer confidence indicators. The problem there is that who is putting these comments on Twitter? Who is putting these comments on Facebook? Is it the entire population? Is it a sub-part of the population? And is this population sub-sector, if you want, biased? There's a higher share of young people, a higher share of women, for example, a higher share of higher educated people. And not knowing this in advance, we would need to have other ways to correct the information that we have. So definitely this is a very good question and a very central point for the rest of our discussion. Let me now hand it over to Nikki, who will go from this very generic and general perspective into the more concrete set of activities that we are running in the European Statistical System under a project called Vision 2020. Nikki.
Thank you. Thank you, Emanuele. Hi, everybody. Thank you again, Emanuele, for introducing also the issue of the data revolution, and to say that the answer of the ESS is the ESS Vision 2020 portfolio, and we are going to see an overview of the projects that the portfolio includes. And so the presentation, it has 3 main areas. The first part, we are going to see in overall the ESS Vision 2020 portfolio, and in the second part, we are going to see the projects that includes the portfolio, and in the third part, we are going to have questions and answers. But before starting with presenting the portfolio, I want to recall you why, what is a portfolio, and why it was decided to be to be managed the modernization on the answer of the data revolution of the ESS European the European Statistical System through the portfolio, because the portfolio acts at the strategic level and brings together projects and programs, and also with the help of various frameworks to enable the strategy in becoming an implementation. So, okay, here we go, and we are going to start presenting our portfolio. The motto of ESS Vision 2020 is bringing the future of European statistics. So the European Statistical System Committee, as already Emanuele showed, the European Statistical System is the big partnership of Europe and EFTA. And the committee is the Directors General of the statistical offices when they meet together. When they met together, they agreed and they realized that the data revolution is changing the information market, and thus the relevance of the statistics, of the official statistics. And this they decided with an immediate reaction and deciding a strategy that takes 5 key areas in order to remain relevant and competitive the official statistics. So as I already said, the European Statistical System Committee is the owner of the portfolio and the decision maker. And but in order to monitor and to follow better the actions and the progress of the portfolio and the strategy, a subgroup was created in order to follow nearer the actions, and it's called the Vision Implementation Group. The chair of this group is Eurostat, and it's contained by 12 member states. The VIN is the Vision Implementation Network, and this part, and it contains the remaining member states of the partnership of the ESS. So in the next slide are presented all the projects that are included in the portfolio, and as you can see, the most of the projects are cross-cutting, and this means that they will influence directly or indirectly all the statistical production process of the European system. So, this was a general overview of what is happening regarding the portfolio at portfolio level. And now we are going to move in a project level. So we are going to see the projects, and each project, the presentation of each project is going to be presented in 3 different slides. In the last slide are given the contacts and the information if you want to know more, or you want to contact the project managers in case you want to collaborate with them, and they are open also for discussions, and in case you are a student, if you want to do the PhD thesis or the dissertation, you can contact them. So they are more than welcome to receive your emails. So the first project we are going to start with regards the administrative data, and it has two main purposes, this project. The purpose is to create the legal basis and to resolve several problems regarding legal ownership of the data or even the privacy law limits in order to enable the NSIs, the National Institution of Statistics, to man the data and to have access to the data. So this project has 7 different work packages, so it's more than a simple project. Actually, it is a program because it has different projects within the projects. So there are different actions running. Okay, here you can have some more information in the press portal, and there is the functional email if you want to contact them. So the second project that is currently active is the ES10, but I cannot introduce this project without doing some small reference in the SimStat and redesign, because they were running together, these 3 projects. The system and redesign is regarded the trade statistics of the NSIs, and it was the 2 projects were enabling 20 member states on a direct microdata exchange of the trade statistics in a way to reduce the costs and the burden, because each country used to collect the export data, and the import data it is collected from the other countries' exports. So the ES10 is what we call the data highways of the ESS, because it's where the microdata can run in a safe way. And if you want, so it's basically fostering the ET capacity of the member states in exchanging the microdata. The DigiCom project focuses mainly on the users and our clients, and it's our answer to what the more increasingly user needs are becoming. Because now the users, they want more tailor-made information, and they want also to empower them to use and to combine data. So this project is also a kind of program, because it has 4 working packages. And in this slide, you can see already some of the deliverables that this project has. I invite you to click on the links for viewing the shared infographics. These shared infographics are available for all the European Statistical System. And now, of course, we have also the Facebook page, which is quite important for the diffusion and increasing the statistical literacy. The ESPRS is a project which is what I consider brings the European Union closer as a concept and as a project, because the issue that deals with this project concerns the multinational enterprises groups. The issue that wants to resolve this project is that when you have the data of an enterprise at the national level and the enterprise is multinational, you haven't got the clear picture of what is happening and you haven't got all the information. So with this register, all European information, all information, they get together. There is a collaboration of the countries, and already, as you can see, 32 countries are involved, and 300 multinationals are already profiled, and you can only get the right picture of what is happening with these enterprises, only gathering and working together and collaborating together as NSIs. The big data project, the expectations on regarding the big data projects are very high. The purpose of the project is to manage and to arrive at a certain point to have the answers for high quality in order to enable the national statistics and the European statistics to integrate the data, the big data. And here I'm going to show you, instead of explaining to you what is doing this project, but has a lot of pilots running and issues running within it. Here I want to show you the potentiality of this project, because here we have the data of census 2011. I'm not sure that this is an area that regards Belgium, most probably. And here we have the mobile phones data on 2015. And you can see that the population intensity is exactly identical in the two icons. So we have still to work on the methodological level, but there is still potentiality. The SERF is the last but not least project, because here the purpose of this project is to create a common shared service catalog, and also to offer a shared environment within the ESS. So instead of having 28 or 32 tools that they are in each country, and maybe they differ from them, I don't know, a statistical package, I'm saying now JDMetra, we can have it in a cloud, and thus no replication is necessary. But these projects, they cannot stand alone. They need to work and to be harmonized within them, because it's because not only it's correct, it's also efficient, and it gives a higher quality on the results. So there are 3 different frameworks that they are cross-cutting in each of the projects. The first framework is quality, and okay. Okay, and it's in each of the projects they have a quality aspect, and that's where this framework enters. So it's the role of quality is to coordinate the quality aspects across the ESS Vision 2020 portfolio, but also to monitor how the expectations of quality and the terminology about quality, it changes and is involved in changed through the years. There may be it will be necessary, it might be necessary to be revised the code of practice. The enterprise architecture is the framework where it gives the answers regarding using the common language for describing what the business does of each project, and to give the answers on regarding what IT systems and the services are needed in order to achieve these goals. So the enterprise architecture works a lot on the capabilities models and puts together the common capabilities and that they are in the various projects. For example, the Digicom, the SERV, and the ESPRS, they have common needs. The cooperation models regard basically the skills and is going to be the tool for filling the skills gap for the NSIs, for the national institutions, when it will be the moment for the deployment of the projects. So, summing up, the vision suggests establishing common platforms for data storage, processing, and analysis in order to run the production processes more efficient and effective at the European scale. So in this is the last slide regarding the portfolio, and you can see the website, the functional email if you want to contact us relating issues and questions regarding the portfolio. The last link regards an explanatory video clip that speaks about 5 of the projects of the Vision 2020, and it's a nice video clip, short story that speaks about 3 national institutions somewhere here in Europe, and shows how it gets better our life with the portfolio, with the ESS Vision 2020 portfolio. And any questions? No? We're waiting for a question, maybe. Ali? Yeah. And from Germany. Is the brochure available in English? Yes, it is. Only in English. If you go to the website, here, you can find the brochure. Most of the material is available only in English, actually, regarding the Vision 2020. And also the video clip is only available in English. Will the European Statistics Code of Practice change with reference to the innovations and using big data? Most probably, yes. We don't know yet because it's still active. And so it's what I showed you, it's the work in progress. So it doesn't mean that it's going to be changed, but most probably if the way of working is going to change, and I think it will be changing. It's possible that it will change, but it's a personal guess. I don't know. I don't know, honestly. So I show. So we are going to pass in the more practical issues. Oh, there is another question. Okay. When will be the Code of Practice be revised? No, we don't know yet. No, I cannot answer this question. If you want and you are interested, please email to me. You have on the first slide the email, and I will contact the quality team, because actually my work is to coordinate the project managers of the portfolio. So I'm not expert within each subject. So I'm going to give the floor to Dario, that he's going to speak about more practical issues and the challenges of the methodology.
Okay, so thank you very much, Nikki. So I'm Dario Buono from the methodology unit. Here you find my details and the disclaimer. So, and if you want, you also have my Twitter account that we are using quite a lot these days. If you have questions, please don't wait until the very end of the presentation. Just type the questions in the chat so that I can have a look while presenting. So what I'm going to talk about today is mainly four things: methodology at Eurostat, what we actually do, our challenges in terms of filling the data gaps that are available, and something which is a little bit new, at least here in Eurostat, trying to deal with data analytics. And then I will speak about a little bit of the results of a project we did when trying to use big data for nowcasting purposes. So most of you might already know that Eurostat is a statistical office, and what I'm trying to present here in this slide is that we are about 700 people with different nationalities, and our core business, in also especially methodology, is the second bullet point that you see here on the slide, which is working for harmonization, identifying best practices, and provide guidelines and training, and also to be there in the international events. The methodology team, we mainly deal with some aspects of the statistical methods that are available, and mainly we work on time series, econometrics, statistical disclosure control for the access to the confidential data, and we also have a team which is dedicated to the research and the enterprise architecture. We do produce a lot of we disseminate kind of a lot. We have different formats for the products that we are disseminating. So you have some articles in Statistical Explained, which are mostly user-friendly. Then we have statistical books where you find data, but also analysis of the data. And as I mentioned before, we have manuals and guidelines that are normally those recommendations to be used in the ESS. And we also recently have tried to relaunch again the statistical working paper collection by Eurostat. I will mention something later, because actually we're the outcome of one of the projects that I will talk about is actually a paper that we have produced. We have recently introduced also a new collection, the statistical reports, and we also do leaflets, brochures, infographics. We do it mainly all for the different audience. There you find the Eurostat website, and for your information, we have had the Twitter accounts for 5 years now, and this year we also started with a Facebook page as most of the statistical office, and we try to reach the public audience with that channel. So, as I said, the methodology team, the part is centralized, so we have a central unit which is dealing with methodology, but we also have many methodologists that are a little bit all over in our office. And in this slide here, I'm trying to share with you a little bit what are the skills that we are in, and also the teams that are we are dealing with in our daily job. So you can see that we mainly cover all the phases of the data collection process, from data collection, processing, validation, but also we have in our core activity mainly data analysis, time series, and econometrics. And I thought it was also nice to share with you this graph because something new that we are learning, it's also about network analysis. So basically, what you see is the results of an internal survey that we have done, something that was done, if I remember well, also in Italy some years ago, and it was also a good opportunity to learn how to use network analysis. Here it's a little bit unfortunate that you don't actually see on the slide what this slide was meant to, and actually these are supposed to be the tools that are mostly used here in Eurostat, and here on top, on the bottom left, actually the first bar that you see is the people that are able to use R in our institution. The second one is the one that are using SAS. Here you have eViews, and you have Stata, but MATLAB. And what is kind of interesting maybe also for you is that these small bar charts that you see there are actually about 2 new tools that I see with interest that are coming more and more demanded in the office, which are Python and Adobe. And also you have then most of the classical tools like SPSS, Java, but also other things. And in the next slide, you will see what are the other things that we do or that we are trying to do. And you see that it's a mix of new and old tools that are still used and some new that are going to be used. Let me say that here in particular in this slide, I'd like to mention about the ArcGIS, which is the one that we are using for the geospatial statistics, and maybe also the Fuzzy Logic for the Monte Carlo sensitivity. Now, as Nikki said, in methodology we work a lot also with member states, and I thought to share with you this slide on the way this is organized. So here what you have in front of you is the structure of our directors, so the Eurostat directors that is meeting with the member states directors, and they meet together with the methodology and the IT experts. And you see here at the second layer level, the working groups that we are organizing, and I think it's interesting to know what are the main topics that we deal with. So you see that there's a shift between quality, methodology, standards, and IT. And so at this level 2, basically all member states are represented, and at this layer 3, only few member states are represented, and so here we really look in the area of the experts, and we have topics that are they range from seasonal adjustment to standardization to information model, but also to security. This is just to give you an idea what are the main area in which we work with the member states. Now, this was a little bit the part about what we do methodology at Eurostat. Now I'd like to maybe put together all things that Manuel and Nikki said before, because then in the end, the real problem is that we have to fill the data gaps. So we have to ensure a better use of survey data, and mainly the idea is that modeling can help, to have more robust estimates. And then on the other side, some work that we are doing is in the direction of what here I call flash estimates, but you can read also as nowcasting or rapid estimates. And the idea is mainly to combine the survey data with administrative data, or to add the new data sources such as the big data to improve the timeliness of the estimates. And I will talk about the project we did later in this presentation. So basically, the main three challenges, or the main work streams we are working along, is that to profit from the multiple sources, and actually so these are, if you want, our three pillars in methodology. We have to profit from multiple sources, and the idea there is that this should be for the purpose of decision that should be taken on based on evidence. And we do have an initiative that we call it Data for Policy, and if it's interesting, I can maybe share later some additional information on this initiative. The second part is about data integration. I think this is quite clear to most of us, to try to integrate the traditional data sources with the new ones. And as I was telling, what is kind of new, it's about data analytics. And in this respect, I have kind of prepared, so if you want, this is what we see, it's the data-driven world, the context. So the idea is that what we are producing should be what is demanded by the users. And we still believe that the value added of what we are doing, it's in the way we do it. So that's why we are investing in, we're still investing in methodological aspect, but of course what is becoming more clear and clear is that what is important is also how you visualize what you are doing, and if you are able to provide this required information as a service to the users. And as I announced, I think that the real future is about data analytics. And maybe in this slide we can have a look a little bit to the different dimensions of data analytics. So if into these two Cartesian axes, you see here is the descriptive analytics, what we are currently doing nowadays, which is mainly about explaining or giving to the users a scenario of what happened. So this is what we are mainly doing now. And what I see coming is that we will do more and more diagnostic analytics, predictive analytics, and prescriptive analytics. Because partially we are actually doing why something happened, if you want, it's part of that analysis. But what we're still not doing at Eurostat, and as all the few statistical officers are doing, it's to investigate in the predictive analytics what will happen, and then finally the link with the policymaker, so the prescriptive analytics, how we make this happen. So some of you might say, there is nothing new in this slide, these things that we knew it already. But I also think that if there is a new fashionable word that comes, it's also useful sometimes to put yourself, to know where you are in this new framework. So as I said, then I would now move a little bit to this example on the use of big data. We have heard also from the presentation before that we have to use big data because these are smarter, are available immediately, and maybe are more focused on for what you want to do. So then we have seen that there are different data sources that can be used, and actually an exercise that we have done is actually to use the Google Trends data for nowcasting purposes. And so what I'm going to talk about now is about this project, which is you see now underlined in bold, which is the big data macroeconomic nowcasting. And I'll talk also a little bit about where you will find the outcome, the methodological findings of this study. Some other things that we have done is also to work on the early indicators of inequality, to reduce the time lag for the estimation of GDP from 45 days to 30 days. And also, if you are a follower of the inflation data, you might have seen that we also have some nowcasting of the inflation that comes after the day after the end of the month. So as I was saying, one of the projects that we have done in methodology is to focus on big data and macroeconomic nowcasting. The idea is that the big data are maybe interesting because they come from a different information set. These data are more granular and are timely available, And last but not least, something that is very much appreciated in our office is that generally are not subject to revisions, which is one of the main features that we try to always deal at the end of our statistical process. So basically what we did, I mean, our research question there was if the use of big data could help to improve the macroeconomic nowcasting of our modeling. So the project was really about, if you want, we took a classical approach. So we started from to have a look in the literature, and then we tried to identify which were the models or the methods to be used for big data. And actually at the end, maybe what was the big learning or the recommendations is that we tried to identify what is the statistical process or what are the steps that you would take when you are trying to use big data to improve your nowcasting. And building on these recommendations, we have done a couple of case studies, and I'll tell you later what are the results so that you'll be surprised. So of course then, this stage when you try to do something which is a little bit out of your daily work, you go out there, and we have done a small research project with some universities that are mentioned here in the slides, and some consultancy company there, which I'd like to acknowledge for their cooperation. So the first starting point is that we have to find an agreement on what big data are, and basically if you look in the literature, the more quoted one is the one that you see now on the screen. So you have total data where you have many observations but few variables, fat data when you have many variables and few observations, and huge data when you have many variables and many observations. So this, just to tell you that to find an agreement that we would use this definition and not something else, took a couple of months of discussions. And I really suggest you that, I mean, in the paper that we've published, there is an extensive review of the literature references, so you will find all the definitions. So then what we did was to run a model race, if you want. So we took the classical and a mix of classical and new methods that are used, like the dynamic factors and partial PLS, the Bayesian regression, and we have made them compete in terms of forecasting precision with loss regression, UMIDAS, and model averaging. So basically, we have done 255 different models that were tested, using macrofinancial data and Google Trend data. Let me say that regarding Google Trend, this is mostly known now, but basically here we are talking about keywords that are searched on Google for which you get time series back to the past directly from the Google website. Before I go to the recommendation, these are the main findings that or if you want the main learnings. So we do believe that at least for our case, the sparse regression, the last two, they work pretty well for fat and huge data. We also believe that data reduction techniques for using the dimensionalities like the PLS are always helpful for when you're dealing with many variables. And in case of mixed frequency variables, think about monthly and quarterly data in the same model, the UMIDAS and the bridge modeling is what we are looking for. Of course, this is not the new Bible. These are mainly the findings of our research project, so don't take it for granted. I mean, this is just what we found out based on the pilot we did. So then we thought that another side product of our project might have been to provide some recommendations, in line with one of my first slides. That how do you go from the data access to the modeling when you are trying to using big data to improve your statistical process. So basically what we have done, we imagined to have a step-by-step approach with specific recommendation per each step. So, and we started from the identification and the choice of the big data you might want to use, the pre-treatment, which is actually part also of the classical statistical process, and the econometric modeling, and then how do you evaluate the results to decide actually if the big data that you have used for that purpose are useful or not. So basically, the first step, it's not very different from the traditional steps that you would do. I mean, as I said in the beginning, our initial research question was that we do have a model for doing nowcasting, and the question is that can we improve the accuracy of this model by using big data types basically coming from Google Trend. So the first point was to assess the initial quality of our model before adding big data. And the other, in this, so the big question is that, is this really useful to try? And then, our expectation is that big data would have helped to actually to increase the quality and the timeliness of the nowcasting. And also having in mind that the lessons from the classical statistical approach, we said, okay, we should not consider big data sources which have a spurious correlation with the target variable. So this is some, the first recommendations that we have. So then regarding the type of big data, I mean, mainly you have three kind of sources, which are either the social networks, or the traditional business systems, or what are now called the Internet of Things. So data that are based on sensors that are machine generated. Of course, the choice is heavily dependent on the target variable for the nowcasting exercise, and in our case, we mainly used, as I said, the Google Trend, which are based on web scraping. Now, something else that is important before you start doing your simulation is that you should anyway look if these data are going to be, if there is a kind of guarantee that the data are going to be available and will not disappear at some point. And sometimes, to have a metadata infrastructure would also help. And the other idea is also that, big data is anyway a data set, so there might be a bias in the data. So bias correction should anyway be done, as in all the traditional data set. I mean, the idea here is that it's not necessarily true that data that are available anytime are better or are not unbiased. So you still have to do some bias. You might have to do some bias regression. And of course, the other recommendation is that the model you find today at some point should be or might need to be respecified, at least on a regular basis. So once you have identified, so in our case it was the Google Trend data, what is interesting to do at this step is to do a proper mapping. So because big data are especially unstructured, so they have been not designed for statistical purposes, they do have a structure which is mainly linked to the velocity by which they are generated. So a proper mapping is also really good, and especially it's a good preliminary step for the pretreatment and for removing the deterministic pattern that you might find. And by removing the deterministic patterns, we still have in mind the outlier detection. If in our case it was time series, so removing the calendar effects, seasonal adjustment, dealing with the missing observation, and so on. And another recommendation that we might have here is that here this is the very timely moment when you want to think about a specific IT environment where you would store also your routine, so that then you will be able to replicate your results. And of course, the traditional recommendation at this point also try to ensure the availability of exhaustive documentation, which might be time-consuming, but is going to be very helpful. And I will tell you that for us it was very helpful, especially for the follow-up project that we are running in this year. So, as I said, here are some additional details on the methods that we believe are interesting to be used. For nowcasting with large data set, this can be based on factor models, large BVAR variables, or shrinkage regressions. The huge data set, as I said, can be handled by the sparse principal component, but this can also be combined with some linear modeling or a variety of machine learning methods such as lasso and lasso regression. I know that some of you that are maybe following, they might disagree that we classify the lasso and lasso regression until machine learning, but at least this is our understanding. And for the mixed frequency, I think I already mentioned these results before. And regarding the evaluation, we do believe that in the end, this was an exercise where we were trying to improve the accuracy of the forecast. So the traditional criteria, MSC and MIE, are the one that we would suggest. I see that time is running, and maybe I'd like to say a couple of more things, because actually what I think is interesting is that when we arrived to the case study and we've done some simulation on the industrial production growth, the inflation and the unemployment in some EU countries in a kind of out of sample context, actually the results are mixed. So the main finding is that in terms of forecasting gains, generally the big data did not really help a lot in improving the accuracy. Of course, the reasons might be different, because maybe the model was already really good already in the beginning. So the main learn is that now we know more or less how to do. We know all the steps. We have an idea of the approach. But we are still learning. And so for this reason, and I see a question that is from Tesnomira Tesnova, about if there is a written description of the nowcasting model with that I'm mentioning here. I mean, you find here in this slide the link to a working paper that was published, and it's available in our Eurostat Statistical Working Paper collection. So you will find it on our website, and maybe we can also share the link later. And actually also regarding the methods, this is a forthcoming in one of the Eurostat and the United Nations Handbook on rapid estimates, which possibly will be published this year. So what's next? What is next is that I think that from the lesson learned from the exercise is that basically we thought, okay, maybe we started too little. We had a look into a too specific problem, so the nowcasting, and we thought, okay, maybe let's become big now, really big. And so then the project we are currently running now is something called the Big Data Econometrics, so where we start from the more general framework, and then we try to go into details. Without giving too much details, here the idea is that we will have at the end an air package which will be shared and where you will be able to reused. And we also think that what is written here on the new ways and new metrics, we also see a potential of the big data, not necessarily in improving what we are currently doing, but especially in maybe measuring something new. So that's why I hope that we will also find new metrics. In a nutshell, here you see the main. If you want, this slide is a little bit to sum up what we said. So from methodology, the main elements are multimode and multi-source approaches, use algorithms and maybe data mining technique, or a new inference or estimation method. From the IT environment, the challenges are mainly about solutions for handling with big data, and from one side, and from the other side to still ensure confidentiality and security. One of the biggest challenges still remains the data access and sources. Someone asked before if this will be maybe part of the code of practice. In my personal opinion, it should be, but at some point it will be, but I don't know exactly when. I mean, the code of practice is 60 years old, and it survived many revolutions, many other revolutions so far. So it might survive also this one of big data, we will see. But for sure, the access to the big data is maybe the most challenging part. Because once the data are there, as big as they are, if you're able to find a structure, then you're able to work with it. And also the other challenge that I see coming is regarding the skills. We go more and more, there is a shift between the classical statistician that should become at some point a data scientist, and this would require maybe a combination of statistical and IT skills. So this was pretty much what I wanted to say. I see that there are two other questions from, maybe I take one from Ireland. So the first one from Laura, how robust are the forecasting estimates compared to the more traditional forecasting results, and are they already being used in official statistics at EU level? Okay, so as I said, in the learning from the first exercise I've done is that actually in terms of forecasting, of accuracy of the forecasting, the gains were not very, very big. I mean, marginally in some subsector, the use of Google Trend were improving the accuracy. As I said, we consider this as being a research product, so it's not really part of the official production yet. As you know, there are other webinars that will be focusing on big data in the EMOS series, so maybe you will learn more there. And also I'd like to take this other question regarding to what extent, still from Laura, data protection, security, and confidentiality are a challenge for big data. And maybe this is a question, I see that Emanuele is back, it's more for him to reply to this question.
Okay, let me get into the picture. First of all, thanks for the question. I think it's very relevant. In fact, it's the same question that the Director Generals of the European Statistical System discussed among a few others just a week ago in Malta in a summit that was dedicated to discussing the future priorities of work for the European Statistical System. The short answer is that we need to strike a good balance between providing access to data which are in private hands but not privately owned, so meaning data that are in the hands of platforms, for example, or provider of services, and ensuring confidentiality and data protection. I do believe, and I'm not alone in this belief, that the statistical community is competitively placed in being, in fact, on the frontier of protecting data confidentiality, because we have been and we are using a huge amount of data already in the production of official statistics, subject to data protection and confidentiality requirements. So we have a legal infrastructure, a technical infrastructure, and a methodological infrastructure that has been solid and built over the last 2 decades. Obviously, this infrastructure would need to be tested in the context of new data sources, which are more complex, higher volume, more variability. But the basic tenets of this infrastructure, including the methods used to provide statistical confidentiality and statistical disclosure controls and ensuring confidentiality of the data, are there. So they need to be adapted to a massive databases. They need to be incorporated and included in the algorithm. But in the sense, the basic notion that you have a trade-off between the amount of information that you are disclosing and the risk of re-identification of the individuals, it's an optimization problem that needs to be dealt with in mathematical and statistical terms. And this very concept is a key ingredient in the discussion that the statisticians are going to have with the data protection authorities at European level and in the countries. Moving into a dialogue where questions are framed in terms of probabilities and statistical approaches to data protection, I think will be a key value added. And just to answer the part of the question about data access, we are currently working already with the data providers in terms of establishing partnerships on the basis of memorandum of understanding, and some of the pilots that my colleagues reported to you are based also on the results of this partnership. But to make this access to data for the official statistical community a more permanent feature of the system, we would also need to change the rules of the game. So there would need to be a new legislative framework. In some countries, for example France, this has already happened. The digital law in France allows the statistical office to have access to some of the a large portion of what we would call big data. In other countries, this is already embedded in the national legislation, and we will be making efforts at European level in partnership with the other services of the European Commission to move towards a legislation that would allow the use of big data sources for public good, and statistics is a public good.
Well, thank you very much, Manuel. Maybe I'll take this last question from Carlo from Luxembourg. So to what extent do you think big data could affect independence and or impartiality of the official statistics? Well, here I'm going to share my personal opinion about it. I really think that the independence and impartiality does not really depend on which data you're using, but depends a little bit more if you're able to be transparent about what you're doing. And that's why our approach also with in this project for using big data for nowcasting was let's start and let's take a methodological approach. Let's research. Let's be transparent. And also in that line, that's why we published the early results on the methodological approach to be followed, even if the results of the pilot were not so encouraging as maybe the methods that we have identified. So I see that also Germany is happy about the presentation. And I'm not so sure, Heli, if now the floor goes to you, or we wait maybe for some other questions.
I can take the floor, but I see there's still a question a little bit higher up. You see Cenova.
Okay, so let's wait for more. Let's wait for more questions to come. Then.
Maybe you can reply those questions in between. Is there a written description of the nowcasting model with the macrofinance data used by ISTAT or Eurostat?
Yeah, I've already replied to that one. I mean, as I mentioned in the slides, there is a publication on the Euro Statistical Working Paper which is available, and the link is in the slide.
Just as a general comment, the slides contain links to websites and repositories where several of the results that we've been discussing are contained. But also feel free to contact us. I think you can find the contacts on the first slide of the presentation, the direct contacts. Email would be the most effective way. So you can contact all the three authors, the three speakers for this communication anytime, and we will be very happy to answer your questions and redirect you to sources of information in case you need to read the whole paper or the background material for each of the topics that we covered.
Also the project managers. The project managers are looking forward to receiving your questions and who knows, maybe future collaborations. Yes.
All right. So
to Morocco from us.
Yeah. I think we are wrapping up. There are several thanks. So we thank you for your attendance, being patient, and bearing with us until the end. Again, question about can I have this presentation? I think this was answered, but maybe...
Yeah, I mean, just to reply to everyone, maybe it's not following me, the connection will remain open for another half an hour, and you will be able to download the presentation at the end. So if you are interested, just wait, and then you will download. If you think about it, you change your mind, you want it tomorrow, just send us an email, and we will send you the presentation.
Okay.
Ellie goes back to you now.
Okay, then I would say basically thank for everyone, especially for Emanuele, Niki, and Dario for sharing your insights and views on this topic. And we look forward to meeting Dario again later on in April. The next EMOS webinar will take place right after Easter on the 19th of April when Markus Zwick from the Statis will talk us a little bit more about big data in official statistics. And as it was said, I would close the session here. I will change the view into something different, so the webcam will disappear. But you will see there at the bottom that there is a space where you can download the slide set on this part where you see 2 megabytes. So I will